Hello folks, so in this video I want to talk about how we can solve quadratic equations, and we actually have done this already for, in the context of talking specifically about quadratic functions, like when we're finding their x-intercepts. But in this, these next couple videos, I want to talk about how we can kind of generalize that process and really just solve any quadratic equation. So first off, what is a quadratic equation in the first place? Well, that's just, an equation that involves some kind of x squared, where x squared is the highest exponent, highest power of x. And you'll see an example of this. You are great at solving linear equations already. So a linear equation would be something like this that doesn't have an x squared in it. So like if you wanted to solve 2x plus 7 is equal to 3x minus 14, you'd be great at solving that. Move all the x's to one side and then solve from there. Okay, so what would be an example of having to solve a quadratic equation? Well, let's pretend we have this graph and this function y equals negative x squared plus 12x minus 20, and I've graphed it right here in Desmos. And my question to you is, what is x? What is x when, that looks like a y. That should be what is x when y is equal to, say, 12. All right. Okay, now first off, based purely on the graph, we know that we should be able to see that there are two answers. So y is equal to 12, so that's going to happen 1, 2, 10, 11, 12. It should just count up from there. And there are going to be 2. And we could actually kind of see that already from this graph. We can tell this x value is going to be, this one looks like it's 4, and this one looks like it is 8. Okay, but pretend I didn't have the graph. Okay, so how would I do this? Well, when we did it with, you've done this with a linear function. You've seen problems where you know what x is and you need to find y. And you've also seen problems where you know what y is and you need to find x. So we're just going to do that here. So we're going to plug this in. 12 is the new y value. And we're trying to solve negative x squared plus 12x minus 20. Okay. We have a slight problem here. Well, not problem, but something that's slightly different than what we have been doing before. Whereas before, if I wanted to find the x-intercepts, you would set 0 equal to y, and then you would, set up your equation. And then you would factor it, assuming it's factorable, and then use the zero product property. But a slight problem here is that, the only reason this works right here is because this is a 0. As is, we can't use the zero product property. Because again, z and ZPP stands for 0, meaning that the one side of the equation has to be 0, which it is currently not. However, we can make it 0, and if you can, this is a general strategy in a lot of math equations, is that if you can make one side equal to 0, it actually kind of enables a lot that can be done. So I'm going to do that by just subtracting 12 from both sides. So if I do that right here, minus 12, and we'll get 0 is equal to negative x squared plus 12x minus 32. And you can always do this, right? You can always just move, once you have the equation, again, all we're looking for is we just need to play around with it and to get x by itself. Or to use some other technique like factoring in this case. So now that I have one side of the equation equal to 0, if I can factor the other side and get it as, a bunch of factors, this times this times this, then I can apply my zero product property. Now again, this is dependent on this being factorable, which this one is. So let's do that. Now, me personally, I think it's a lot easier when your x squared term is positive. When it's negative, for me, the signs just get kind of weird. Not to say that it can't be done, but I'm going to do that by factoring out a negative 1. Alternatively, you just take the entire left side and move it to the right side. Well, actually, this makes more sense. Is that I'm just going to take the entire equation, both sides. I'm just going to go multiply it by negative 1. Sorry, because there's no reason I couldn't do that. Times negative 1, times negative 1. Okay. So when I do that, I'll get still 0 on the left, which is why this is really awesome. And I'll get x squared minus 12x plus 32. I won't go through the factoring process in this video because I assume that you can do that. But we should end up with x is equal to, x minus 8 and x minus 4. Like so, leaving us with two answers. Either this piece equals 0 or this piece equals, oops, sorry, not 4, 0. And therefore we get two solutions where x is either equal to 8 or 4, again, as expected. Okay, so that's definitely one way to solve quadratic equations. Whenever you get any kind of equation where you have, x squareds in it, if you can get one side to equal 0 and then factor the other side, then you're golden, and you can just use your zero product property. Again, we have a slight problem is that this does not always work because, we've seen plenty of times now, where you can get a quadratic expression that is not factorable. And in the next video, we're going to take a look at how to deal with that.